Let's do section 11.1, page 542, exercise 39, which reads, refer to the region bounded by the x-axis and one arch of the cycloid. X equals a times t minus sine t, and y equals a times 1 minus cosine t. And for exercise 39, we're supposed to find the area of the shaded region, and I've drawn the graph over here. And there's a hint, which is to remind us that dx is equal to dx dt times dt. So to find the area under the curve, we start by slicing the region into smaller rectangles, and then we add up the area of all those rectangles using an integral. So I'm going to make my slice here, and as I've said in class, one of the most important things is to figure out what the thickness of your slice is going to be, because that is going to determine everything else. So the thickness of my slice here is going to be dx, and the height of my slice is going to be y. So when I try to find the area, it's going to be the integral from 0 to 2a pi of y dx. And then we usually substitute in for y. So I'm going to have my integral from 0 to 2a pi of a times 1 minus cosine t dx. And now there's a problem here, because my function is in terms of t, but I'm taking the derivative with respect to x. So we need to reconcile those two things. My variable and my d whatever have to be the same. So one option would be to try to solve this in terms of x, but I think that's going to get sticky. So I think the better thing to do might be to use the hint, which says that dx is equal to dx dt times dt. And that would let us convert our dx into a dt. So we need to start by figuring out what dx dt is going to be. So I need to take the derivative of this, and I'm going to get a times 1 minus cosine t, and then I'm going to substitute in up here. So I'm going to have the integral of a times 1 minus cosine t, and that's what I got from my y. And then I'm going to multiply it by dx, which is going to be a times 1 minus cosine t times dt. But my original limits for my integration were in terms of x, and now I want them to be in terms of t. So I need to resolve that, and I'm going to have, remember, x is equal to a times t minus sine t. Let's give ourselves some room here. So when x is equal to 0, what do I want t to be equal to? Well, if I let t be equal to 0 as well, then both sides of this would be equal to 0. So my lower limit is going to stay t equals 0. My upper limit is 2a pi, and I want to figure out the t value that is going to go with that. So my a's are going to cancel here. And really the only way I'm going to end up with 2 pi is if I let t be equal to 2 pi. And then the sine of 2 pi will be 0, and I'll just be left with this term here. So my new limit for t is going to go from 0 to 2 pi. Now I can pull out an a squared here, and then I'm going to perform my algebra. I'm going to multiply this by this, and I'm going to get 1 minus 2 cosine t plus cosine squared t dt. And then I should be able to integrate this term by term. So I'm going to have my a squared. When I integrate the 1, I'm going to get t. When I integrate cosine t, I'm going to get negative 2 sine t. The problem is going to be this integral from 0 to 2 pi of cosine squared t dt. And of course, this whole thing is going from 0 to 2 pi. Now, there's a couple different ways you can do this, but one useful way is to look at the integral table on page 622 of section A7. And that integral table tells us that the integral of cosine squared ax dx is equal to x over 2 plus sine 2ax over 4 plus a constant. And I can use that up here. So I'm still going to have my a squared on the outside. I'm going to have t minus 2 sine t. And then for my integral, I'm going to substitute in this. So I'm going to have t over 2 plus sine 2t over 4. And we need to evaluate all of this from 0 to 2 pi. So now we're ready to substitute in our limits of integration. I've still got my a squared out front. So I'm going to have 2 pi minus 2 times the sine of 2 pi plus 2 pi over 2 plus the sine of 4 pi over 4. And then whenever I substitute in 0 for all of these values for t, I'm going to get 0. So I'm not even going to substitute in. My 2's are going to cancel there. The sine of 2 pi will be 0. The sine of 4 pi will be 0. So I'm going to end up with my area is going to be 2 pi plus pi. So that's going to give me 3 pi times a squared.